Look at the smooth, exacting precision of this automated robotic arm. In industrial manufacturing and high-level laboratories, this kind of accuracy is a strict operational requirement. A deviation of a fraction of a millimeter can compromise an entire production line. To guarantee that accuracy, facilities must continuously test and adjust their measurement tools. This process is mandated by strict international regulatory frameworks, like ISO for Global Quality Management, CE for European Conformity, and JIS for Japanese Industrial Standards. But on the actual factory floor, the tracking of these vital calibrations is often archaic. Technicians scribble measurements into paper logbooks or manually key data into fragmented Excel spreadsheets. Records get lost, handwriting is misinterpreted, and human error consistently corrupts the compliance trail. The standard solution to this chaos is Enterprise Calibration Management Software, or CMS.
These are heavy, complex systems that require expensive, dedicated servers, constant database maintenance, and specialized IT support teams to keep them running. This creates an operational vacuum. Small to mid-sized manufacturing facilities find themselves trapped. They're caught between the chaos of paper records and the bloated, expensive infrastructure of enterprise software. Securing true regulatory compliance has forced these facilities into a corner. They have to choose between operational friction on the floor or financial strain in the IT department. Qualitex Trading's QT CalibrateID bypasses both of those extremes. It is a digital calibration management system that requires neither paper trails nor heavy IT infrastructure. This illustrates its Zero-Dependency Architecture. On the left, there are no backend servers, external databases, or app installations. Instead, the entire system operates natively, running entirely within a solitary web browser. The system bridges the physical tool and digital record using NTAG216 NFC chips, small, inexpensive radio frequency tags that are physically attached to the measurement instruments themselves. When a technician physically taps the metal tool with a standard smartphone, the browser instantly opens the digital application. Because the NFC chip holds a specific web address, loading the tool's unique identity data, its precise serial number, and required calibration intervals, all completely filled. In Step 2, the technician enters their calibration data. As they input the nominal and measured points, the browser automatically calculates the deviation. It then dictates a simple pass or fail status based on the pre-programmed tolerances. By pushing all of this identification and validation logic directly to the front-end interface, the system removes manual data entry and mental math. It neutralizes the two highest sources of human error in the calibration workflow. But this raises a technical question. If there is no back-end server and no database, how does the system remember the technician's data as they navigate through a multi-step workflow? The HTML5 local storage API saves data directly on the device. Step 1 and 2's data slides into a memory vault. Next, Step 3's ISO and JIS flags append to it. Finally, Step 4 converts a touchscreen signature into text data, completing the stack. At the climax of the workflow, the system reaches into that local vault and pulls all of the accumulated data simultaneously. It merges the identity, the measurements, the condition, and the signature to generate a single, highly traceable, unique certificate ID. By leveraging local browser memory to compile the workflow, the smartphone itself briefly functions as the entire secure processing plant. It removes the requirement for expensive external databases during the actual act of calibration. To finalize the process, the web app packages this assembled data payload and routes it directly to a registered inbox using a secure email API. The operational result is immediate. The facility receives a fully compiled, print-ready PDF certificate that proves exact regulatory compliance, generated entirely without data ever touching a proprietary backend server. This image of 5 basic code files resting on a pedestal illustrates the system's deployment advantage. Because QT CalibrateID consists exclusively of front-end code, just HTML, CSS, and JavaScript, it can be hosted anywhere. It functions on free static servers or internal hard drives with zero marginal hosting costs. While this version operates on the front end, the architecture is designed to scale. It maintains the agility to integrate with cloud databases or transition into a progressive web app, or PWA, when a facility requires enterprise-level inventory tracking. QT CalibrateID proves that rigorous international tool compliance is no longer a heavy infrastructure problem,
By relying on native browser capabilities and NFC tags, maintaining precision is now a lightweight, decentralized process, accessible with a single tap.